Hello students, in the last tutorial we discussed the first phase, which is the connection establishment phase in the TCP protocol. Next, once the connection has been established, as we know, we can have bidirectional data transfer because TCP supports full duplex communication. So now let's look at how actually the data transfer happens. So a sequence diagram is shown in the slide here. Okay, so this happens after the connection establishment phase is over. So here in this example you can see that the client is sending two segments. Each segment is carrying data of about 1000 bytes, and the client is actually sending two segments. And as you can see here, the client segments are not only carrying data, but it is also acknowledging the data that it has received by the server earlier. Okay, and in the opposite direction you can see that the server is sending 2000 bytes as a single segment. Okay, and if you look at the first segment that is being sent by the server, apart from the acknowledgement being set, okay, there is another special flag called as the push flag that has been set. But before I come to the push flag, let's also have a look at the sequence numbers and the acknowledgement numbers. The sequence number is 8001. Okay, and then the acknowledgement number 15001 indicates that the client has received up to 15,000 bytes from the server, and the next byte it is expecting is from 15001. So in response to this acknowledgement, you can see that the segment here, the segment being sent from the server will have a sequence number of 15001. Okay, so it is sending data of up to 2000 bytes numbered from 15001 to 17000. Once this packet is being received, the client again sends an acknowledgement in the reverse direction, and in this time the acknowledgement number is 17001. Okay, so this can continue till both the clients and the servers have some data to exchange with them. Once the data transfer is over, they can move on to the third stage, which is connection termination. But before we move to the connection termination phase, uh, let's have a look at the data transfer phase itself. As discussed earlier, both the client and the server can send data and acknowledgements in both the directions, and the acknowledgement is not sent as a separate segment. Rather, we can say that it is piggybacked with data. So by piggybacking we mean that we place the acknowledgement onto a segment that is carrying data in the opposite direction. Okay, so here if you look at the first segment, the highlighted segment here, it is carrying data from the client to the server, but at the same time it is also acknowledging the segment that has been sent from the server in the opposite direction previously. Okay, up till byte number 15000 by setting the acknowledgement number as 15001. Okay, so this is what we mean by piggybacking. Okay, there is no separate segment for sending the acknowledgements. Rather, the segment that is carrying the data will carry an acknowledgement also. Okay, so this process of placing the acknowledgement in the segment carrying data is called as piggybacking. Okay, which acknowledges the data in the opposite direction. So as was said, if we look at this diagram here, the client sends about 2000 bytes of data as two segments. Okay, so in the first segment it sends data numbered from 8001 to 9000. In the second segment it sends data numbered 9001 to 10000. In response to this, the server may send a single segment which is 2000 bytes long. So if you look at all these three segments, the first three segments, all of them carry the acknowledgement fields, acknowledgements in the opposite direction. The last segment, if you observe here, it carries only the acknowledgement because there is no more data to be transferred. So it sends only an acknowledgement. This segment contains only an acknowledgement. And the data segments sent by the client have a special flag called as the push flag that is being sent. So if you see the flag in the control field, you will see that apart from the acknowledgement flag, even the push flag is set. So what we mean by what is the significance of setting this particular flag? So sometimes as we have discussed earlier, the TCP on either sides use a buffer to store the stream of data coming from the sender application. So we are talking about this sender side TCP. This sender side TCP, what it will do is it will store the stream of the data that is coming from the application. Typically, it is not the case that the data that it receives from the application will be immediately put onto the communication channel. Rather, TCP uses a buffer to store the stream. So there could be several reasons. One reason could be for efficiency. Okay, if the data generated from the sender application is small, then just creating a single segment for each small amount of data that is being generated will result in more number of segments to be transmitted. Rather, what the sender TCP usually does is it keeps the application data sent from the sender application into a temporary memory that we know as buffers. Okay, we already discussed the buffers. These are circular buffers that are there both at the sending side and the receiving side TCP. And the sending TCP can decide upon the segment size. Okay, so once your contents of the buffer reach the segment size, all this data can be written onto the segment and sent across. But in some cases, this may result in delayed transmission. Okay, if the buffer is not filled up to a certain point in time, then during that duration no segments are sent. So this may be problem in certain cases, especially if the client is interacting or client is transmitting data in an interactive manner. So by interactive manner, we mean that there is a continuous interaction between the client and the server. Client sends a response and the server has to respond back with a response to the request sent by the client. And if the sending TCP suppose starts waiting for the window to be filled, then the response from the server side will be delayed. And because of this, okay, if we are working with an interactive application where the responses should be delivered in real time, then the sending TCP should not wait for its window to be filled. Rather, whenever some data is being written by the sending application into the sending TCP, it should be immediately sent. So how do we give this preferential treatment to such applications? So for this particular purpose, okay, the sending TCP will set the push bit. Okay, if the push bit is set to 1, which means that we should not buffer the data, rather we should immediately send it to the receiver. And when this is received by the receiving TCP on the other side, when the receiving TCP looks at the segment and sees that this push bit is set, what it will do is it will immediately transfer this segment to the receiving application program rather than keep it in its buffer and wait for more data to come. Okay, so this way the applications on the server side and the client side can run in an interactive manner. Okay, so what you have to understand is the push bit will be set only if the data should be sent immediately from the client to the server, okay, without being buffered. In such cases we use the push flag. Similarly, there is another flag called as the urgent flag. So as we know, TCP is a stream oriented protocol. By stream oriented we mean that the data shared between application programs using TCP will be shared as a stream of bytes, a continuous flow of bytes. And sometimes an application program needs to send urgent bytes. Okay, so do not get confused with the push flag, push bit and the urgent bit. So the urgent, so we need to understand what we mean by this urgent byte. So when we are sending some data as part of a TCP segment, some part of this data might be considered urgent. By urgent, it is not to be understood as immediate delivery. Rather, it should be considered as a data that should be handled in a special way by the application at the other end. Okay, so in such a case, what we do is the urgent bit is set. So once the urgent bit is set, we will now also make use of another field in the header. So if we recall, in the TCP header we had a field called as the urgent pointer. Okay, so how do we make use of this urgent pointer? So whenever a TCP wants to handle a particular part of the data that is being sent in a segment, sent in the segment in a preferential manner, then it keeps this urgent data as the first bytes of the segment. But now comes a question as to, okay, the urgent data is starting at the beginning, but how much part of the data segment should be considered as urgent? So to answer this question, we have another field called as the urgent pointer. So let's take an example and try to understand how to interpret this urgent flag. Suppose say the segment sequence number is 15,000 and then the value of the urgent pointer is 200. Okay, so once a segment let's say is containing 1000 bytes of data is being sent, whose first byte is numbered 15,000, then we are sending bytes from 15,000 to 16,000 and the value of the urgent pointer is 200. So by looking at this urgent pointer, we come to know that the urgent data starts from 15,000 and goes on till 15,200. So this urgent pointer gives us the offset from the starting sequence number, how much amount of data should be considered as urgent data. In this example, the urgent pointer being set to 200 means that the initial 200 bytes of data should be considered urgent. So when the receiving application looks at this, it gets to know that it has to handle this data in a priority manner. Okay, it has to be treated differently, and the remaining data should be considered as non-urgent. Okay, the thing that you have to understand here is, even though certain data might be marked as urgent, it doesn't mean that it will be immediately delivered, as in the case of the push flag. Okay, if you want immediate delivery, you should set up the push bit. If you want certain amount of data in your segment to be handled in a special manner, then you are going to use the urgent flag. Okay, so you need to understand the difference between urgent data and pushing of data. Okay, so this way the data transfer can happen. Once the client and server have finished their interactions and they no longer want to have any other communications, then we can start the third phase, which is the connection termination phase. So either of the parties can initiate this. Okay, either of the two parties involved in exchanging data, which could be either the client or server, can ask for closing the connection. But mostly this connection termination phase is usually initiated by the client, because typically the client is the one which places a request, and then in response to that the server places a response. Okay, so this process continues as long as the client is placing some requests. At some point the client might have finished all its requests. Then now the client no longer wants to continue with this connection. So what it does is it initiates the process of connection termination. This connection termination can be done using two mechanisms. Okay, one is the three-way handshaking, and the second method is the four-way handshaking with a half close option. Okay, we will look into both these variations. Both are mechanisms for terminating an already established connection. So here first we will look at three-way handshaking. So this is used by majority of the implementations of the TCP protocol. So once the data transfer is over, the client process intimates the client side TCP saying that it wants to terminate the connection. So in this case, the client side TCP moves into a state that is called as active close. It will create a segment, okay, which will have a particular sequence number. In this case it is X, and an acknowledgement number Y, and it is acknowledging the data that has been received in the other direction. But apart from this, if you look at the control field here, there are two bits that are set. One is the acknowledgement bit and another one is the final bit, F bit, or the fin bit. So such a segment wherein the fin flag is set is also referred to as a fin segment. Okay, and this fin segment is sent after the last chunk of data to be transferred is actually sent across, and this is just a control segment. Okay, it does not carry any data. If you see here, this is not carrying any data part, it is only consisting of the headers. Okay, and that's why it's called as a control segment. This fin segment, even though it doesn't carry any data, it still consumes a sequence number. So once the client has sent this fin segment, when the server receives this, the server now gets to know that the client wants to terminate the connection it has established with it so far. As a state of approval, the server will send a segment which acknowledges this fin segment sent by the client. Okay, so if you look at the acknowledgement number sent by the server, it is x plus 1. Okay, which means that we have received bytes up till x. And at the same time, okay, so in this scenario, once the client wants to terminate the connection from his side, the server is also no longer interested in keeping the connection from its end. So this will also send a segment which has the fin flag set. So here in this segment, both the fin flag and the acknowledgement flag are set, and that's why this is also called as a fin plus ACK segment. Okay, so it is doing two tasks. The acknowledgement is acknowledging the fin segment sent from the client, and at the same time it is also saying that it wants to terminate the connection from its side as well. So when this control segment reaches the client will also agree to this connection close request from the server, and it moves to the connection closed state, as you can see in the diagram here. And then it also lets know the server that it has terminated the connection. How is this done? It sends again a acknowledgement segment in the reverse direction, acknowledging the request for terminating the connection from the server side. Okay, so at this point, when the server receives this acknowledgement, the server will also close its connection from its end. Okay, so this is how the three-way handshaking happens for connection termination. Okay, so let me repeat it again. The client will send a fin segment. Okay, fin segment indicates that the client wants to terminate. The server acknowledges this fin request by sending an acknowledgement in the reverse direction, and at the same time also sets the fin segment saying that it also wants to terminate the connection from its end, and this will result in the client closing its connection, and the client will also send an acknowledgement back which will result in the server also to terminate its connection. Okay, so this is the first mechanism of connection termination, called as the three-way handshaking. The second way is called as a half close scenario. So why we call it as half close is, one of the ends will stop sending the data, but the other end can still keep sending the data. That's why this is called as a half close. When do we come across this half close scenarios? This a good example of this is in sorting data. Okay, let's say that there is a client which has some data to be sorted. The client sends this data to the server. The server is going to perform the sorting part and reply back with the sorted result. So once the client has sent the data to be sorted, it doesn't have any more data to send it to the server. At this point, we want the data transfer to be terminated from the client side. But however, we cannot close the connection from the server side, because the server takes some amount of time to sort this data, and then it has to send the sorted data back to the client. Okay, so if you look at the first segment being exchanged here, the client has sent a fin segment. In response to the fin segment, the server is only sending an acknowledgement. You should compare it with the previous one. In the previous case, in the three-way handshake termination phase, apart from acknowledging the connection termination request from the client, the server would also send a FIN request. But here, no such FIN request is being sent. If you look into the second thing, there is no FIN flag that has been set. Okay. At this point, when the server acknowledges the connection termination request from the client, the connection from the client side is closed. From here on, the data can move from the server towards the clients, and the client can only send acknowledgements in the reverse direction. It cannot send any data. Okay. After some amount of time, the server side TCP wants to terminate the connection. Okay, so again, if we go back to our example, the server has finished sorting the data and it has sent this data to the client side TCP. Now that the computation is done and the client also is not interested in any further requests, the server now sends a FIN segment. Okay, this particular segment, saying that it wants to close the connection from its side, and the server will the client will acknowledge this request for connection termination by sending an acknowledgement, at which time even the server closes its connection from its end. So this four-way handshake is also called as the half close. This is the scenario by which the TCP connection termination phase happens. Okay, so far we saw how a TCP connection can be established using a three-way handshake, after which we saw how data is being exchanged, and for all the data that has been sent, the acknowledgements are coming in the reverse direction, piggybacked on the data itself. No separate segments are created. We also saw the significance of the push and the urgent control flags and what is their meanings. And once the data transfer is over, we move on to the connection termination phase, where the connection is terminated. All the resources allocated are going to be released. This connection termination can happen either using a three-way handshake procedure, where client and the server together close the connections from their ends, or we can have a half close scenario. Typically one of them can close the connection from its end and the other can continue. Usually this happens with the clients send their data and request for closing their connections from their end, and the client closes its connection. The server is now able to send data in the opposite direction. The client can reply back with acknowledgements. Once the server is also done with sending all the data, the server will also terminate its connection from its end. So this is called as the half close connection termination. Okay, so we'll stop here. In the next lecture video, we'll discuss the finite state machine that captures the overall working of the TCP protocol.